right, hello everyone. Apologies for our technical difficulties. I am Jake Lussier. I'm product lead for the Flying Car Nano degree. And since this is a brand new Nano degree program, we thought it'd be a good time to just open up for questions, let people ask questions about what flying cars are, what the Nano degree is, anything that comes to mind around the curriculum, careers, anything. So this will be a time where we'll have a couple different slots in the next half an hour where students can message in any questions they like. To start though, I'll just give a little bit of background about myself and what brought me to the Flying Car Nano degree program. So as a little bit of background, I've been working in data mining machine learning for over 10 years now. A lot of my work used to be on the web, and then when I got to Stanford for a PhD program, I started working with Sebastian Thrun, the Udacity founder, and we started doing a lot with, well, he's been doing robotics for a long time, and I started working in perception robotics. So we did crazy stuff like inventory tracking and something like Amazon Go almost, and I actually spun that out, worked in it for a little bit, but then on the side, through weird twists and turns, started working a bit in flying cars. And that path led me here. So now I'm heading up the Flying Car Nano degree, and we're super thrilled about this program and really excited to share it with you all and answer any questions that you might have. So I guess to get started, we'll just talk a bit about the program, how it runs, and what kind of topics we'll cover. So this is a 6-month program broken into 2 terms, and each term is 3 months long. So the first term is going to be aerial robotics. So you can think of this as just the foundations to get a robot to fly, hover, move in interesting maneuvers, not necessarily going full-on flying car yet, but just how do you get something to fly and how do you get it to fly autonomously. So in this first term, we're going to cover estimation, controls, and planning. Usually those might be covered in that order, but in the spirit of getting you flying stuff quickly, we're actually going to switch up that order and do it in reverse. So we're going to start with planning. So you'll have the opportunity to immediately get your drone to fly around simulated environments. And even if you port your code to a real drone, which we'll talk about later, you can get it to fly around in specific paths in, say, your backyard, as long as it's safe. And then we'll move on to controls, and then finally into lower level estimation. So that's all term 1. And again, that's the foundations building up to a full-on flying car curriculum. It's the second term where we then cover intelligent air systems, where we're going to go a bit more advanced. We're going to talk about flying car specifics, and we're going to move even beyond a single flying car, and we're going to talk about entire complex environments where you might have collections of drones, collections of flying cars, all of those moving about autonomously in a coordinated and safe fashion. So in that second term, we're going to start off with a primer on fixed wing flight. So a lot of what we call flying cars differ from drones in that they're not just quadrotors. They might be either full-on just regular fixed wing planes, or they might be some kind of hybrid VTOL design. So the very first module in that second term is going to be about fixed wing flight. From there, we'll go on to more of topics in fleet coordination. So we're going to have a little bit about mission optimization. And then we will have more about coordinating all of these vehicles in a way that takes into account the communication between them and also to a central coordination system. So in a lot of different countries, this might involve governments in some way. So that's just like a very high level overview of what we'll be covering in the course. I think as I mentioned earlier, the application window for this first inaugural term is actually closing very soon. So you have until Wednesday at midnight Pacific time to apply. And we think this is a really exciting opportunity for these students to get in the very first cohort and also have a one-time offer where the typical tuition will be discounted 25%, so you actually save $300. So we definitely welcome all applications for the entire duration of this Nano degree. We're extremely excited to see applications this first time around. So that's a bit about me. That's a bit about the program. So I guess what I'll do now is I'll launch into a little bit of Q&A. We will get to live Q&A, We got a lot of questions submitted beforehand though. So just to start, we'll start going through some commonly asked questions and some specific questions from some specific students in our Slack communities. So, okay, so I guess the first question, appropriately so, is what do we mean when we say flying car, and how does it fit into the future of air transportation? So this is a bit of a tricky one. I would say that to define flying car, it's useful to think about when people ask, how is it actually different than a helicopter? And that's a good place to start, because when we think of a helicopter, some really important features there are that helicopters right now are really difficult to access in that they're quite expensive. They're difficult to use in that they require really sophisticated training. If you've ever even just tried to fly a quad rotor drone, there's like all these different controls, and just to not destroy it, you have to actually be quite skilled. So it's expensive, it's difficult to use. And a helicopter with its single rotor is actually not safe really either. So they're not used so widely that we see accidents in, say, urban environments, but they're actually, in terms of accidents per ride, they're quite dangerous and they're not super reliable. There's not much redundancy built in. So think about that as a helicopter. So then what is a flying car? It is essentially a flying vehicle that on all of those accounts offers improvements and is in some way almost opposite to a helicopter, which is to say that a flying car is a flying vehicle that provides easy access in that it should be quieter, it should be cheaper, it should be easy to use. So the autonomous controls, or at least intelligent controls, should make it so that it doesn't need expert licensing or perhaps any pilot. And also it should be tremendously safe in that, again, the autonomy provides safe ways to navigate, and also the design of the vehicle offers redundancies. So a flying car doesn't refer to any kind of one design or one use case. It more refers to a vehicle that fits these descriptions, and in doing so is able to address more everyday use cases. And I think that last part is a really important feature of what we call flying cars, is that we're not thinking of helicopters that are when you go on vacation to some island, and we're not thinking of planes for when you go from San Francisco to LA. We're thinking about more, you go to work and you have a long commute, and there's going to be a day where everyone flies every day. So these features and that kind of imagined use case really gets to the impact then, which is that as we want more people to move more often, as we want more goods to move more often, as we want even our services to move more often, and as we want them faster, right now, a lot of our transportation exists in a world where people are collecting in 3 dimensions and going up into tall buildings and doing so all at the same time for work, and then all going to 2 dimensions and getting congested at that time with these natural bottlenecks. So all these aerial transportation solutions offer the opportunity to break that constraint and have things fly to us immediately, seamlessly, cheaply. So this is the promise of the flying car, also of drone, but for flying car, this is the promise specifically for transportation. So that's a bit about flying cars, a bit long-winded, but I guess in summary, it's just easy to access, easy to use, safe, flying vehicles that we use for everyday use. Now, I guess this dovetails nicely into the next question, which is how do drones relate to flying cars? And what role will they play in the future? So a lot of the things that I just described go back to this point of trying to move things. Right now we're stuck in 2 dimensions. Right now we want more of those things, which is making that system even more congested. And as I said, flying cars allow you to break that constraint. So drones have that same advantage. Obviously, when we're talking about drones, we're talking about smaller vehicles that are moving lighter packages. So I think we can think of drones then as these flying vehicles with these features that are optimized to move goods to us, especially light or urgent goods, very quickly and very, very cheap. So they're not really designed to carry, a sofa. Probably in the future, if you want to order a sofa and have it delivered next day, you'd be better served by a self-driving car than a ginormous drone. But when you look at what's being delivered to most people daily, there are these statistics like, let's see, Amazon, 86% of their packages are under 5 pounds. And Walmart has said that 70% of all Americans live within 5 miles of a Walmart. So when you combine these two, a lot of things that we're trying to get moved to us are actually very amenable to what drones can provide. So again, I think the short answer here is that the value proposition of the flying car, drones have a very similar value proposition for moving light goods to us immediately, again, in an everyday use case. So those are great questions. Super appreciate on the high level points of flying cars and of drones. So those are very frequently asked questions that we see all the time on Slack. So now to get to some specifics, we have this one question here submitted by Nigzit Patel. And the question is, what type of drone should we get for the course? And what are the sensors and other hardware required for the course? So this is one that we're actually going to share out a post about this maybe today or tomorrow, where we talk more about what students will be building and how the development path will work and culminate in some building on actual physical systems. But as a little bit of a teaser, I guess what I can say right now is that you don't need anything. So if you just want to learn the fundamentals of autonomous flight, and if you want to be able to practice with those and get real world experience, but in simulation, the Flying Car Nano degree is already something that you can tackle, and you'll have everything you need to have an experience that is offered nowhere else and will prepare you really well for your career. That being said, we know that a lot of students really value the opportunity to port their code to hardware. I think especially with drones, it's really magical to see something fly. So not just in simulation, but to be able to have it on a big drone outside or a little drone right in your office. And we also know that experience doing so isn't just fun, it's also something that is practical. And when you go to job interviews, if you can say, and even better yet, show where you've gotten your code running on a real robot, that's super powerful. So with that in mind, we are offering a couple recommendations for a fully featured, a bit more heavy duty, but still DIY drone, and then another very inexpensive drone that is not heavy duty, but is something that you can just fly around in your house. So on those points, on the first one, in the classroom, we're actually going to be doing a lot of instruction and explanation with the Intel Aero, which is a drone that has both the autopilot and the flight computer. So in addition to running low-level code on the autopilot, you can also even run your Python code in a very high-level way for problems that aren't super time sensitive and don't need to be real time. So we'll be offering a bit more detail on that, but the Intel Aero is one really good solution for this course. It is a bit heavier duty, it is a bit larger, it is a bit more expensive. So on the other side, we will also be pointing students to the Crazy Fly by BitCraze. And that is a drone that, when you get the STEM bundle, can actually be less than $200. And I actually just tweeted out the other day a picture of one of our team members, Tucker, flying it around in the office and just being able to poke it down and have it come right back up. So I think these two options, depending on what you're really looking for, are really, really good and can provide you with some real world experience getting these things to fly. So again, in summary, you don't need anything if, say, you can't afford anything, or if you don't really have an interest in a drone buzzing around, then that's fine. And absolutely you'll have everything you need for this course. If you so choose to get drone hardware, then we'll point you to those, and we will also provide instructions for the code that you'll be developing in the classroom, how to get that onto your drone easily. So hopefully that's clear. If there are any other questions, feel free to ask now, hit me up on Slack, and I'll be happy to offer more clarification. Hopefully we'll do so a bit more formally in the next day or so. Okay, so another question now by Abdullah Altawatan. Apologies for pronunciation. The question is, are we going to design an attitude controller, for instance, PID or LQR? Also, what kind of microcontrollers are we going to be using in this program? So I think Andy Brown, our curriculum lead, is going to be able to offer you really detailed explanations about these, probably far better than I. But what I can tell you is that at a high level, you'll be designing a nonlinear cascaded controller, which basically means that you'll have these different controllers that involve some nonlinearities, and you'll be developing and implementing that whole system. As part of that, yes, you will be designing a PID controller, and specifically, yes, you will be doing it for attitude. I guess since there are likely a good number of students from the self-driving car community out there, I think that since it is a PID controller, it will be similar to what you develop there or in robotics. But in robotics, in aerial robotic systems, the control problems are a lot more challenging, dynamic, a lot more variables to consider. So it will be a unique challenge too, to look at how you control a drone specifically. Okay, so the next question we have here is from Bernd Reitberg. And the question is, regarding the program, will we be learning to control the autopilot of drones as well? I'd love to control my drone in extreme weather or try to program extreme evasive maneuvers, such as flips and stuff. All right, so I guess on that question, again, the answer is yes. So, and for a bit of background for other listeners who might not be as familiar, on a lot of drones there is both the flight computer, which is used for higher level computational tasks, and the autopilot, which most of the time I would say people aren't tinkering with because that's much lower level controls. In this program, we are trying to really offer a broad look at the entire system and really give you expertise and experience in the full stack. So with that in mind, yeah, in this program, planning is an example of a problem that you can likely just have on the flight computer. But then as we go into control and estimation, and we're trying to do things that require a high frame rate, in those situations, yeah, we'll be having you write things on the autopilot in simulation, and then if you want to port it to your drone, then yes, you would do that as well. And for your funner aspirations here, yes, we'll also, as part of our projects, we'll be hopefully having you not just control a drone in very stable maneuvers, but get to play around with doing more acrobatic maneuvers and also like slalom and a bit more advanced things. So I think we'll do that, if I'm not mistaken, both in first term and second term. So that should be pretty fun and pretty cool. All right. Now, a second part to this question is about autonomous flight and regulation here. So it's which countries do you think are best prepared for autonomous flying drones? So that's a big question. I would say that there's a lot of exciting innovation happening in startups in a lot of countries. Maybe we can discuss that a bit more later in terms of which startups are doing what kinds of things. I think you see it in the States. I think you see it in Europe, in Asia, South America. You're seeing really interesting large companies and startups do a lot of different things. So I think they're all really positioned to try to lead this area. I think regulation, it's obviously a complicated question, and it varies from location to location. I think we're being pleasantly surprised though. So if we take the United States, for example, the FAA is being quite innovative and doing a good job at supporting innovation. So for example, in building the unmanned traffic management system, they're doing a lot of development themselves, and they're also working with the private sector to try to understand how to best develop this system. So while maybe sometimes it might slow innovation, I think it's natural and necessary in this world where we do have robots flying in the sky, so it needs to be extremely safe. And I would say in general, they're doing so at an appropriate pace and actually stimulating a good amount of innovation. So I think the regulatory bodies are acting appropriately, and a lot of countries are going to have really cool opportunity to really transform transportation in their countries and abroad. Okay, so let me see. All right, I have some additional questions here. Okay, so I guess a first one here from Musab is, in the intro of the course, the professor showed a PX4 autopilot. Are we going to learn how to build our own autopilot or just learn how to interface with existing autopilots? Yeah, so I guess I would offer one small correction, say not just learn how to interface. I think that's a really important thing to learn how to do too. So, and in this Nano degree, we will offer you an opportunity to do both. So as I mentioned before, students will absolutely, when building low-level control and estimation code, have the opportunity to dig into what an autopilot system looks like and get to play around a bit with how they would handle low-level considerations like that. But as you go into the real world and you build a career in this space, I think a lot of engineers will be not digging down deeply into those parts, but actually building on top. So a really important part of this program is also saying, here are some interesting open source, widely used tools out there, such as the PX4 autopilot, and how can you use that? How can you develop on top of that? So both of these will be really important. So I guess I will answer just one more and then we'll move on. Okay, this question from Musab is, will AI and machine learning topics be covered in the program? So that is a really good question, and the answer is yes. I think as someone who comes from data mining, machine learning, and AI, flying systems provide actually a super interesting domain to experiment and work on AI, in that the current supervised learning classification algorithms out there that have been riding this wave right now, and most people can just kind of use them as black boxes for certain narrow use cases. Those have some applicability in the domain, but really it's a more challenging environment where safety and reliability are really important constraints. So I think in the Flying Car Nano degree, you'll get to see what machine learning looks like in autonomous systems when you have to be extremely aware that your robot's in the sky, and that if you have an algorithm that you just treat as a black box and you think on average should work, it's just not sufficient. So you have to be creative about how you use machine learning. But still, we will cover how machine learning is used in flight autonomy. Okay, so I think that's maybe a good first batch of questions. So moving on, I think it would maybe be good, before I continue answering some questions, to talk specifically about one area where I know a lot of students care, and there have been a lot of questions, which is just the Flying Car Nano degree and how it will prepare students for careers, and specifically careers in the space. So the very high level point here is, yes, this Nano degree is a job-ready, career-focused Nano degree, just like robotics, just like self-driving cars. And as with any of these Udacity Nano degrees, we will offer students clear advantages and tools in three important ways that are, again, typical of everything that we offer at Udacity. The first is that what you'll be learning and what you'll be building in the course are directly useful in industry. These are informed by our conversations with industry leaders, both really large and really small startups. So what you'll be learning and the projects that you'll be building, we're really confident that when you go to interviews with these kinds of employers, that you can show them this stuff and they will immediately recognize its applicability and be excited about what you've built and what skills you have. So first one is just, we're going to prepare you really well in the classroom. Second one is that we, as I alluded to, we do work really closely with industry. So we are confident that everything that we're offering is relevant, and also that as you reach the end of your time in the Flying Car Nano degree, that we can position you for success in this area. So this leads into a third point, which is that in the Udacity Nano degree, we also have a rockstar team in the careers team at Udacity that is dedicated entirely to student success. So you'll learn relevant things. We have connections to hiring partners, and then we have careers team at Udacity that can make sure that you know how to prepare for interviews, that you know where to look for the right jobs, everything that you need, given all the expertise you will have built to go out and find a career. So that's generally high-level Udacity things that are true for all of our nano degrees. And I think another point here to make for flying cars, in that I think a lot of people have questions like, okay, flying cars are not as established as machine learning or even as self-driving cars. I think an important point here is that in this nano degree, we're going to be offering a look at the full stack for intelligent air systems and flight autonomy. So the skills that you build there are, I think, really applicable nearly everywhere in modern technology companies, and that you'll be learning about machine learning, control, estimation, software development, robotic systems, autonomy. So with the skills, you can potentially apply them outside of the field if you'd like. Then beyond, or perhaps within that, there's the aviation sector, which even if you're not looking at, flying car startups, it's already, we see that autonomy is disrupting a lot of these current systems. I mean, if you look at planes, for example, already, the plane that you take to fly across the country, it's already flying itself for most of the trip. And even during takeoff and landing where a pilot is involved, it's already leveraging technology and autonomy a lot. So there's all these jobs outside of aviation. There's even kind of like maybe old school aviation that is being disrupted by these technologies. And then we do think that the drone industry is already growing really rapidly. And especially in Silicon Valley, we see that the flying car industry is taking off really quickly. And having Sebastian involved in this program especially, we're able to get kind of an inside look at how these companies are growing, what they need, what engineering talent shortages they're seeing, and how our students can plug into this now and certainly in the future. So that's a bit about careers. There's all this stuff that Udacity offers all of our nano degree students, and for flying cars specifically, we think that there's an existing industry and a really rapidly growing smaller one in flying cars and drones. So that's just to speak a bit about career specifically, because we know that that is what a lot of students care about. So again, if you have any questions, feel free to shoot them over now, or direct message me on Slack, or ask our community. So I guess now we'll move on to a bit more Q&A. So, I guess the very first one says specifically what career opportunities will be presented after the nano degree program. I think we just spoke a bit about that, but to be even more specific, I think, autonomous system engineer, software engineer at all of these drone and flying car companies in the Valley, really even like data mining and machine learning positions at these companies. Like there are a lot of software positions in aviation as a whole and in this growing community. So I think all of those positions, when you look at our curriculum, you're going to be super well prepared for any of those positions. Let's see, next here. Yeah, so another one we have is, what is the status of the flying car industry in Silicon Valley, and when will it take off? So I think it's really interesting talking to Sebastian on these issues, because what he has seen and what he makes very clear when he's talking about drones and about flying cars is that there's not any kind of like big science risk. There's not huge unknown technical risk in this area. So the basic science of how things fly is pretty known. The hardware to get things to fly is pretty known. And the software to do so reliably is pretty known. But the thing that is perhaps missing is more of the system level innovation, where you take all of these known elements and you combine them and you show how building higher level intelligence on top of that can provide a reliable and robust transportation and mobility system. So I think that's the stage that we're at right now in Silicon Valley and abroad, where we're seeing a lot of these parts being put together. And it's kind of a lot of simultaneous invention, where we see certain kinds of VTOL designs, certain kinds of imagined systems, and we're seeing these tackle really important problems. So it's kind of putting these things together and really starting to take off into hopefully very consumer facing offers soon, because I think that's a huge thing that will be important for the industry in the next coming years, is to immediately start to show value in perhaps like emergency response or even ecotourism or these things, so that people can immediately start to see how drones and flying cars are not far out, but actually really immediately viable and super compelling. Okay, let's see here. Okay, so an interesting one here from James Walmsley is the flying car capable of instrument-only flight or low to zero visibility? So I think, so first of all, when we say the flying car, it's important to realize that, say, unlike large jets for commercial airlines, the flying car industry has not really converged on a single design. So even for the same mission, different companies are coming up with different solutions. And then as the field matures, we'll see, for different use cases, convergence on different designs. So there's a whole bunch of flying cars, but to your question specifically, will it be able to fly with low visibility? It's actually really interesting, I think, for flying cars. It's easy to generalize from self-driving cars and just say, like, okay, it's a big robot, it needs to move intelligently, so it's got to have this like spinning LiDAR system and these cameras and everything, and just think about it as a similar kind of robot but in the sky. But when you think broadly about the different missions that these two kinds of robots have to accomplish, on the ground there's just like so much stuff that you can hit. So for self-driving cars, it's really important that they be able to have really powerful computer vision and sensor fusion systems, so that you can be sure not to hit these things. In the sky, there's not as much to hit. So you don't need to have a vehicle decked out with as much sensors. So in the sky, it's much more a situation of being able to coordinate these different systems and making sure that, so to answer the question, maybe even if you just have like one camera or potentially even no cameras to start, can you fly very safely? So I think if there's really bad weather and low visibility, it's really important that they still be able to fly. And I think it's also very possible that they'd be able to, because unlike the self-driving car system, we have the ability to kind of build this one from the ground up. So yeah, I think there likely will be uses of perception, especially for obstacle avoidance and for precision landing. But I think that we absolutely will see vehicles that can fly even in the absence of strong data from those sensors. Okay, a question here from Dimitri is, how much overlap is there with the self-driving car nanodegree program? So this is a good one. It's one that we've heard a lot. obviously a lot of self-driving car students are potentially interested in the flying car nano degree. And the kind of messy answer is that there are definitely commonalities, and it's for those, I think, a really great opportunity to strengthen your skills. And say if you're interested in self-driving cars, really build your resume and your experience in autonomous systems. And there's also a lot of really specific different considerations when you're in the sky. As I just mentioned with perception, the main challenge for flying cars is not necessarily being able to see a woman flying across the sky, because there are no such obstacles in the sky. So concretely, I think in this program, the first term is going to touch on certain foundational elements of any robotic system. So in that way, there will be some things that you'll have the opportunity to practice that you may have seen in self-driving car or in the robotics nano degree program, but you'll already be seeing new considerations when you're building something that's flying in 3 dimensions and when you're developing using software tools that are used for flight. So already in term 1, you're going to be seeing some similar things and some very different things. And then I think term 2 is where we really can see that it's pretty wildly different than self-driving cars, because the things that we're thinking about then after you built up that foundation is how do you build a flying car? What kind of hybrid design you use between fixed wing and rotorcraft? And then, okay, you have all these vehicles, they're all traveling at, let's say, 120, 160 miles an hour. You can't just brake in the sky. So how would you design a transportation system if there were a minimum speed limit and you all have to keep zooming? And if there are unpredicted things that pop up, how do you make that system robust? So this starts to be where it's not just the same kind of plan and control estimation but in the sky, but entirely different considerations if we're going to build the future of transportation and do so in the sky. So I think it's a really exciting opportunity to build on what you know and learn about entirely new things. All right, Musab here asked, are we going to be using mostly Python or C++? So again, we will be offering a bit more detail on this in the coming days, but I think the SparkNote version is that the development cycle here is going to look like one where you start in the classroom, and in the classroom what's really important is that you get the principles, you get the concepts, you understand them, and that you can kind of play with things to really tinker around and understand what's going on. So there you'll be coding in Python, and you'll be using a really nice, responsive, pretty visualizer with Unity. And that will all be in the browser, so there will be kind of no messiness of getting things set up or anything like that. It's just going to be a really excellent learning tool and a really excellent learning environment. Then from there, for those topics that can stay kind of high level, if they're more planning, mission optimization, fleet coordination, you will continue developing in Python. But for those projects where it's important to do more real-time stuff, it will be important to actually transition that code, translate it from Python to C++. So if the first phase is Python in the browser, second phase for those will, yes, be C++ in a simulator that's a bit more stripped down, but it has more accurate physics and is also just a better environment to do like really real-world testing. And then if you choose to port to hardware, the C++ is really important too, because if you want to get code on your autopilot, then you're not going to do so in Python. So there's going to be this combination of languages in accordance with the use case that you'll be tackling. All right. All right, a kind of fun one, especially given my background here from Mohammed Kazim, is what is the research future in this area if I want to pursue a PhD in this area? So I can't say that I haven't been doing PhD research in flight for a while. I think really excellent resources for that one are going to be our rockstar lineup of professors. So we have Raf Dandria, who's a professor at ETH. We have Angela Scholig, who's a professor at University of Toronto. We have Nick Roy at MIT. We have Sebastian at Stanford. So they have all turned out some of the leading research in this field. But I can tell you, just in looking at what they do and talking with them, there are a lot of really interesting low-level problems in order to get drones to do really interesting things. I think nowadays there are even more so really interesting system innovations similar to what are required to make, say, the flying car industry take off. There are really interesting research problems when you start to think about how, in the case of Raf D'Andrea's lab, for example, how can you get multiple flying robots to be able to coordinate, hit a ping pong ball back and forth, or construct a building together, or do some kind of actually creative things like perform alongside theater, as Raf has done. So I think there's all these systems innovations. I think Angela's doing a lot of really interesting stuff using machine learning for more efficient and reliable controls problems. So I would actually point anyone who's interested to go check out those professors' pages, check out their publications, and then also feel free to hit me up or hit other people up in the Slack to hopefully start some conversations about what we think is interesting in that area. All right, next up. Okay, so I'll give a partial answer to this one, which is there any element of GPS denied flight in the course? This mode is required for a large portion of drone-based solutions that can be offered to clients. And that is from Newman Hanif. So right now, given the focus on both flying cars and drone delivery systems and emergency aid providers, a lot of these use cases actually are going to assume that you have GPS, because they're outdoor systems where that's really going to be how you're localizing and how you're trying to deliver your solution. We are talking about adding on some GPS denied content to the first term because we know that for indoor robotics, which a lot of people are interested in, that you will be denied GPS and that you will use computer vision and sensor fusion to do your localization and your motion planning. So the answer is that right now the main focus is going to be in problem settings where you do have GPS, but we understand that students are interested in that, and we'd love to hear from you guys what you want. And if people are really interested, if we're definitely seeing a strong industry demand for it, then you might see us adding this GPS denied focus. Okay, so I guess if I combine a couple questions here from Alex and from Audrey, there's questions about do you need background and knowledge in robotics, and also do you need the background in physics? So I think what our prerequisite state is that you need a pretty solid background in programming and in software. So you need to be very competent, say, with at least one language, preferably Python or C++, since that's what we'll be developing in. But I think if you've had a lot of experience in any language, and if you're eager to learn, you'll probably be able to do really well in this course. So that's a prerequisite. In terms of physics, we do require that students have a basic understanding of advanced math and physics. So you'll need to learn. You need to know some about probability and statistics, linear algebra, and yes, physics. But if it was like you learned in high school and in college and you understood those back then, you're just a bit rusty, I think you'll do really well just with our curriculum that will help you brush up on those things a little bit. And if students need additional help just brushing up on those things, I think we'll absolutely be able to support that. If you just haven't seen these physics principles at all, it might be a bit tougher, but I think you'll be able to manage if you have some familiarity. And similarly with robotics, we, again, want you to have really strong competence in programming, but if you haven't developed specifically for robotic platforms, this program will still be something that you can tackle and succeed in. So what's really important is just that you know how to code complicated systems. And then we'll teach you kind of the tools that you use in robotics, to specific paradigms. If you're not fully familiar with, say, event-driven programming, we will have these exercises that will build up and make you comfortable developing these worlds. Okay, let me see if there are any other final questions here. Okay, so I guess maybe end on this fun one, given a lot of the self-driving car community here, which is going to happen first, self-driving car or flying car. So I think when I talked to David Silver in self-driving car, what he says for self-driving cars is not so much a question of when but where, and that self-driving cars are already being trialed in certain communities, and they'll be perhaps even fully operational pretty soon. So if you look at, say, Voyage, for example, which is a self-driving car company that spun out of Udacity, already they're working with retirement communities, because it's a community that the value add is very clear. The navigation environment is pretty controlled and known. They have the ability to map things out really in high fidelity. So self-driving cars, you already see in certain environments. Flying cars and drones. Perhaps flying cars, we don't see large fleets that are operational, but I think we can kind of expect them in certain use cases pretty soon. Drones, though, already, for example, Zipline, a company, has a fully operational fleet in Rwanda, because again, they found a use case where the value proposition is sufficiently compelling for the customer, in this case, the country of Rwanda, to take that jump and work with them. And that's because Zipline works with emergency aid, where they shoot off fixed-wing drones, they fly very low-powered, they drop the aid to where it's needed, and they're able to save lives using that technology. So already these things are being used right now, and I think that the interesting question will be in which need states do these different technologies address, and for what kind of scenarios are the different kinds of robots able to kind of most optimally solve these problems. And in the future, I think we'll actually see solutions that are even hybrid, where there could be a robot on the ground, a robot in the sky, that are either collaborating or one and the same. So I think there might seem some tension, but I think it's actually a really exciting place where they'll both be succeeding in doing cool things. So I guess that's maybe all the time we have right now for some questions, but I definitely encourage everyone who is here to continue the conversation in our Slack community, to ask us questions. You can ask me questions directly. And then really iterate again how we're super excited about this program. We think that for anyone interested in flight autonomy and flight systems, this is going to be really useful knowledge, really applicable knowledge, and will help students build a career in the area. So applications are closing very soon, this Wednesday, February 7th at midnight Pacific time. So if you're excited about it and interested in being part of the inaugural class, please do check out that site, apply today, and we really look forward to seeing your application and hopefully to see you in the classroom. So thank you very much.